Hello everyone. In this video we're going to be solving a polynomial equation. To be specific, it is going to be a quartic equation. Let's go ahead and expand both sides first. So I'm going to be presenting two methods, and my first method involves expanding the left hand side. So we're going to square a difference, so that's going to be 1 minus 10x squared plus 25x to the fourth power. And then we can go ahead and distribute the 5 minus 50x squared plus 125x to the fourth power equals 1 minus x. And since x to the fourth is already positive on the left hand side, let's put everything on the left hand side. Bring the 1 minus x over, so you're going to get 125x to the fourth power minus 50x squared plus x, and then finally plus 5 minus 1, which is 4. And that's equal to 0. Great. Now, don't you love quartics? Of course you do, right? So this is a quartic equation, fourth power, and the x cubed is missing, so that's kind of nice. We can go ahead and try to factor this. So here's what's going to happen. You kind of have to, if you're looking for, let's say, doesn't matter rational or irrational solutions in this case, but let's say you're trying to factor this into two polynomials, two quadratics, such that the coefficients are all integers, right? What would you do? You would look at different options. For example, you could try something like this: ax squared plus bx plus c multiplied by dx squared plus ex plus f, right? But that would be too complicated, too many variables. One thing we can use here is, if we're looking for a polynomial with integer coefficients, then we can kind of choose a and d such that their product is going to be 125x to the fourth power. So for example, we can choose a equals 25 and d equals 5, which is going to give us 125x to the fourth power, or we can go with 125 and 1. It doesn't matter which one is which because that's arbitrary. But these two choices, and there are no other choices because 125 is 5 to the third power, and you can only factor so much, right? So we can try these, and at the end we're going to get something nice, because one of the things we need to know is the x cubed is going to cancel out. So you're going to get x cubed from here and x cubed from here. That means ae plus bd is 0. So that just gives you an additional equation that you can use. Anyway, so that's an idea, and definitely you can use this, and you're going to get from here you should get a cubic equation. Now you can solve with the cubic formula. So quartic equations can be solved by turning them into a cubic. There's also a quartic formula, but I don't think you want to know that. If you do, look it up. It's really, really long. And the quintic formula does not even exist, because if it did, it wouldn't fit anywhere, right? But anyways, so with our first method, I'll just spare you all the trouble and give you the factors of this expression, because we don't really have to spend like 3-4 minutes or even 5-10 minutes on factoring this expression, right? I'm just going to give it to you. So if you factor this by trying one of these, you'll end up getting something like this: 5x squared plus x minus 1 times 25x squared, so 5 and 25 work basically, minus 5x minus 4 equals 0. So yes, this quartic is can be written like this, which is nice. And then from here we can find the solutions very easily. By using the quadratic formula, x is going to be 1 plus minus the square root of 17 over 10. And x equals negative 1 plus minus square root of 21 over 10. Of course, I simplified it. For example, in the second one, you would be getting 5, but then we divide both sides by 5, and then we get a simpler expression. So there are 4 roots. At the end of the video, I'm going to show you a graph of this equation, or the two equations that intersect. And looks like they're going to intersect at 4 different points, because this quartic equation has 4 real solutions. Let's go ahead and take a look at the second method. And we're going to verify that we're getting the exact same solutions. Now, let me rewrite my equation. 5 times the quantity 5 minus 5x squared squared equals 1 minus x. Of course, I modified the problem a little bit because as is, it was kind of too obvious, and you're going to realize when I do that. So I wanted to change it up a little bit, to spice it up a little bit, but let's go ahead and manipulate it so we can put it back in the original format. So I'm going to do the following. I'm going to add x to both sides. Actually, I'm going to do an what is that called? Interchange here. So what I'm going to interchange is actually the x and the 5 times the stuff. But in order to do that, I am taking 2 steps here. So subtract this expression from both sides, then you're going to get the following. X equals 1 minus 5 times 1 minus 5x squared squared. Now at this point, the light bulb probably goes on and you're like, aha, I got this. Now, here's what I'm going to do. If you didn't see that, that's okay. Don't worry about it. I'm going to use substitution. In an equation in this form, substitution is very, very powerful because it's going to get you directly to the answer without going through any factorization, any trouble. Well, we do some factorization, but it's fairly simple. So I'm going to call this C, and hopefully you see what I see. Do you see what I see? All right. Okay, so now here's what this means. 1 minus 5x squared equals C based on what I assumed. But that also involves, if you look at this, like replace the whole thing inside the parentheses with C, you get x equals 1 minus 5c squared. So I can also write that as an additional equation. And guess what? This becomes a system, a beautiful system. Because we can go ahead and solve it. It has some type of symmetry. Notice that the x and c kind of can be switched around, but that doesn't mean that we end up with one solution. Because remember, at the end, we're going to get more solutions. Anyways, I talked to myself. I'm going to stop and get on with the solution. So we're going to go ahead and subtract here. 1 minus 5x squared minus 1 minus 5c squared equals c minus x. Then 1 cancels out, and we get 5c squared minus 5x squared equals c minus x. Then I take out a 5 and get c squared minus x squared, which is the difference of 2 squares. I can go ahead and factor it as c plus x times c minus x. And I have 1 times c minus x. And I can go ahead and put the c minus x on the left-hand side. And that gives me 5 times c plus x minus 1 equals 0. Great. So we got 2 factors. The first one means c equals x, or x equals c. I'll probably write it that way. X equals c. And x equals c means c is 1 minus 5x squared. From here we get 5x squared plus x minus 1 equals 0. The second equation means c plus x, or x plus c, is equal to 1/5. But c was 1 minus 5x squared. So from here we get another equation multiplying by 5 gives us 25x squared minus 5x minus 4 is equal to 0. And we get the exact same equations, and the solutions are the same as before. X equals 1 plus minus root 17 over 10, and x equals negative 1 plus minus square root of 21 over 10. So those are going to be the 4 solutions. Let's go ahead and take a look at the graph, and we'll finish up with that. Here you go. I graph both of these functions for you, and you notice our quartic is pretty nice. It's symmetrical, right? Is that an even function? It is an even function. 1 minus x is a straight line, and there are 4 intersection points. And this brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you tomorrow with another video. Until then, be safe, take care, and bye-bye.